Hey friends, good evening. Just kind of warming up the live chat here. I had some internet streaming problems here at the house. I'm not sure this is going to work super well, but I hope it works out all right. So just kind of bear with me there. If you're just joining up, I just popped out of our study group this evening. It was the AWS study group over at CBT. Had about 5 or 6 learners in there. It's a good discussion. We were digging into choosing a data store at AWS. Oh, man. And talk about a salad buffet, a smorgasbord of options for us to choose from. They got search databases, you got graph databases, you got key value relational systems, graphing, search engines, in-memory data stores, time stream, ledger. So just about something for everybody. And that was one of the things that we were getting into tonight. And of course, anytime you're going to get into a conversation about picking a data store, we had to go like way back. We had to go back to the days when disks was a big concern. Some of us might remember this, and why we like relational systems, and then why relational systems are still around and what things are, and then how to begin augmenting what relational systems do for us. So we started off the conversation by getting into data. Because it's all about data. And if you go anywhere in the software world, you go anywhere in the information technology world, you're going to find people talking about what to do with data and the various natures of data, either obtaining it, moving it somewhere else, transforming it into something, writing it to disk, regurgitating it back out in some other format for a report, for an application to some user that's out there. And of course, this is exactly why when you look at the current state of the industry, we have some 400 plus different types of databases that exist out there, and they're all doing pretty good because they're pretty well tailored. Now, hold up just a sec. It looks like I got some streaming problems there. Okay, that's better. So imagine that you got a bridge and you're trying to move people back and forth across the bridge. You can move a bunch of little cars. You could move school buses, you could move dump trucks, and that is exactly what our data store world looks like. We have a bunch of different units of transmission. We have different languages that we can use. We have different interfaces that we send the information through. So all of this kind of adds up to a very complex mix of features and facets that we have to consider as a part of it. So we started talking about the size of transmission, and that's the individual unit of data that you have to send. And then also pair that up with the entire size of the total data store. So you think about the total space consumed versus the individual item size. That's one of the first characteristics. The next part to consider then is the rate and the interval or the duration that you're going to be transmitting. So how often do I send data? How often do I retrieve the data? How quickly do I need that to happen? How long does it take for each one of those interactions to occur? And looking at applications, modern systems, this is one of those ones where we really push things to the limit. That rate of interaction and that level of concurrency, how many people, how many sessions, how many requests we can have at the same time, that all adds up to that piece as well. Okay, so we're thinking size, thinking rate. Okay, after that, then you have quality measurements. And quality is kind of a really big topic. You're talking about the security of it, the integrity of it, the durability of it, the reliability and the availability of the data as well. This is another facet that we were discussing this. And then finally, the kind of last pieces that I was considering then were the language and the interface part of it. When you think about the way that data gets moved around in our world, first, you might have a CSV document, an XML document, a YAML, a JSON document, and that might get pushed through the TCP/IP stack, put into a packet, put into a frame, and then moved across the network, only to have all of that ripped off of it and stuffed through some other language in a database connector onto a file system, which writes it out in some sort of binary format. So there's a lot of mutation of data that's happening there, and it's one of the reasons, again, why we have so many different data stores available to us right now. So when I think about the language, I'm talking about the syntax of the data, the structure of the data itself, the actual formatting that we write the data in. This is another one of the key characteristics. And it's like the difference between writing a record in a table or putting a document in the database or adding a new triplet of some sort to a graph database or a new vertex of some sort. Okay, and so all of those pieces were kind of contributing here, and this is what I was trying to help characterize. The final piece I mentioned on there was the interface. And this is the part where we're thinking it's not only good enough that we be able to get the data somewhere, we have to be able to interact with the systems that need to consume it. And so one of those might be an application that wants to read the data. Another might be a disk that needs to store it, or it could be some other engine. It could be an API, a database connector. And so when we think about these big constraints, this is often some of the biggest factors behind why we would choose a certain data store. The rate, the size, the interval, the duration, and then those language and interface elements. So this was all pretty much what the conversation was this evening. And we went through looking at all the different types of data store options that AWS has. We talked about how relational systems have schemas. They have that ACID compliance. They offer a great way of creating very complex data sets. And they often pretty marginal performance. You can push them to a pretty large limit, especially if you consider the implication of like read versus write traffic. Okay, replicas, the notion of consistency, having multiple masters, those are all relational concerns. So as you start moving into the other models, it's because there's something about the relational piece that you don't require. If you don't have a complex data set, then odds are you can probably go with a key value store, or you could go with a graph database. If you're more concerned about complex webs of relationships, then the graph database is going to be a better fit. Keeping in mind that it doesn't have to be a lot of data. It's more important about the relationships and the connections that you can build in the data. And again, AWS is offering us managed flavors of all of these services, whether we're using RDS and Aurora, or some of those flavors for relational, DynamoDB, or a do-it-yourself Cassandra service for key value stores. If it's going to be a document database, then it could be MongoDB or AWS's new DocumentDB. Okay, so those options are available. And then as you get into things like search or into these other document stores or graph engines, then you have Neptune. Okay, and if you're talking about search, search is a whole other beast. Search is really a document database. So you think about like Elasticsearch, that's a document database, but it has all these special pieces of indexing and query control logic built on top of them to help tune them for that purpose. Keeping in mind that in a lot of scenarios, friends, all these different data stores you heard me talking about, relational engines used to do all of that work for us. And we found that there were good and bad things about that. Cool. Real quick question. I saw a couple of folks are hanging out there. Hello. How we doing tonight? Happy New Year, friends. Let's see if we can get the lurkers to say something to us. I only got a few more minutes. I just wanted to recap our study group this evening. No problem. You don't have to jump in. Okay, so as we kind of got down to the end of that, we were saying it's often because you don't need all the things that the database relational system provided. If I don't need a schema. Again, key values are great. Documents are great. They're very flexible. I can store a lot of different types of info in them in a lot of different ways. So one of the other things then we finally consider then is, what about durability? If I don't really need durability and performance is a bigger part of it, all right, there's somebody. Good deal, my friend. Thanks for hanging out. So if that's the bigger concern, then that's where we get into things like in-memory data stores. In our case at AWS, that would be Elasticache with Memcached or Redis in there, okay? And the whole point is that we want really fast responses coming back, and I'm willing to sacrifice certain types of durability to improve that. And this is where that notion of augmenting rather than replacing things, I'm a really big fan of that. I'm always surprised by how many people think that you have to just replace all of the stuff to get into cloud. Well, that's not the case. And often that's going to be really damaging to you and your value proposition. Instead, I try to encourage people to think, how can we improve the value of what we have right now by adding something to it? And in-memory data stores are a great augmentation of that. In fact, if you think about caching, it's something that we use everywhere. We use it on our mobile devices. We're using it right now as a part of me streaming this. We use it in our data stores, even our disks and our subsystems. They have caching layers built into them specifically to help improve that performance model that we were just talking about. Okay, remember, in-memory is very fast, but it's got those durability concerns right there as well. And often you have a finite amount of memory that you can use. So you can't just stuff all of the stuff into memory, as much as I would love to do that. Okay, so as we look then across all of these different flavors of data stores, it brings us down to the last two ones that we talked about tonight, which was time series and ledger. And these are two of the more exciting recent additions to the AWS catalog. You've got TimeStream, which is a time series database, and you've got QLDB, which is the ledger database. So just my last few minutes here to kind of recap our study group from this evening. When you're talking time series, it's probably one of the more descriptive languages out there, or database structures. You're talking about things that happened with timestamps that happened over a timeline. So I'm typically concerned about when something occurred, maybe how often it occurred, and maybe the difference between when it occurred, or the timing, or the delta, or the change that's occurred over time there as well. And so with time series databases, these are basic data stores that are built with special functions on top for managing time series data. A great example of this is, imagine you have a bunch of stream data coming in from a factory of sensors. Okay, I'm writing it to the table, and stuff is only relevant to me for the first 3 or 4 hours that I'm looking at it. After that, I don't need to keep that on disk in this time series database. So a time series database can help you with those auto rotate and maintaining what they call a data window. And that's kind of that floating time window. I kind of think of it as like counting cars on a highway. You could count the ones right in front of you, or you could expand your vision and maybe count a few more at the same time. Just depends on what view is most important to you in the time series database. And so they give us helpful functions in there to make our lives easier. They also have nice maintenance pieces for helping keep it logical over time as that data develops. Okay, and then the final one was Ledger. And Ledger is just rocking the scene out there because it gives us a very powerful concept, which is, first of all, immutability. The idea that once something comes to rest in this data store, it can only be changed through a congruent cryptographic transaction that would inform with its entirety through a journaling mechanism what happened and how you can confirm that that happened. So this is really important. Imagine that me and I'm going to try Chintaka. Hey, buddy. Imagine that we're trying to do business together. I want to sell him something, and I want to be able to confirm that that transaction was accurate. And Chin, he wants to be able to do the same thing. He wants to be able to confirm that I did the transaction the way that I said I would, and he'd be able to confirm that on his own. And so that's kind of the last piece about the Ledger database. They are cryptographically verifiable. Both of us can run a simple algorithmic process against the records in the database that we're looking at, and we can produce results that demonstrate what that transaction is, how we arrived at that conclusion, and it allows us to confirm the validity of what's happened and the completeness of what's happened. So all told, when we look back across this, it's still about data. It's still about rate, size, durability, and quality, and then some of those language and interface problems that we had. You look across all the data stores, they're doing the same things. And so in the end, tonight we were talking about in our study group how to choose data stores. And I hope that you'll maybe come back and check out some of our other study groups later on. If you have questions, shoot them my way. You can also find me out there on Twitter. My handle is CloudBart, and I would love to connect with you. Of course, you can subscribe as well. They're on YouTube / just look for Bart Castle is the username on there. Really appreciate everybody hanging out tonight. Chin, have a great rest of your week, buddy. And if there's anything I can do to help you guys out, please do hit me up. I hope to see you in a study group coming up in the future. There at CBT Nuggets. If you're looking for ways to get involved, you can join up in the catalog. It's free to join. You can get on into our user community. And from there, we'll be able to take you into some of the different study groups that we have. We'd love to try to extend some of that. I'm also possibly looking at maybe moving into a Twitch model or maybe some other more publicly accessible study group model, because I think there's going to be people out there that want to have some more of these cloud solutions architecting conversations. That being said, my friends, I hope everybody has a great evening, and I'm going to go ahead and check on out of here because I've been talking for like the last hour and a half straight. So you guys have a great evening, and we hope to see you out there in the cloud.